Hi everybody, Ms. Duncan-Taylor here with Kitchen Biology, and today we're going to talk about membranes. Now you've just finished up your at-home modeling of membranes by playing with soap bubbles, and you went through several questions to get the idea how soap bubbles behave a lot like membranes. And so I wanted to use that as a simple model for membrane. The only reason I'm showing you this diagram is because I want to remind you that membranes are not just this thing around the outside of the cell. Membranes are everywhere. There's a nuclear membrane. The Golgi apparatus and the ER are membranes. All of the lysosomes and the peroxisomes are membranes. The mitochondria is a double membrane, and so is the chloroplast is a double membrane. I just want you to understand that membranes are everywhere. It's not just that thing around the outside of the cell. The cell is a labyrinth of membranes. So that's the first thing. The second thing is that I wanted to talk to you about simple membranes and what they're made out of, okay? Now, in the last unit that we did, you learned about lipids, and that lipids are made out of a glycerol triglyceride, glycerol, and they have 3 fatty acids attached to them, and that whole thing together is called a triglyceride. In membranes, that triglyceride has been modified, and what it has is that one of those fatty acids has been removed, and it's been replaced by a phosphate molecule. Now that phosphate is interesting because what it does is it makes the top of this, it makes the top part of this molecule watery, or what we call hydrophilic, and the tails are still oily or hydrophobic. Now soap is very similar to that. Only this part of the molecule, instead of a phosphate, it has a sodium. And that sodium has a little charge to it, positively charged. So here you've got the sodium, a carbon double bonded to an oxygen, and again the fatty acid. So instead, it only has one fatty acid, and again, this part up here is watery, just like in a phospholipid. So a soap and a phospholipid are very similar in that behavior, that they've got a watery head and they've got oily tails. Now, I want to show you what soap is made out of. This is really fast and oversimplified, but that's okay. Soap. The 2 basic ingredients in making soap are lye, sodium hydroxide, NaOH, and some sort of fat. Like this is bacon grease, or you could use an unsaturated fat like an oil. If you use lye, if you use sodium hydroxide and a solid fat, you get a solid soap. It takes several weeks for the saponification process to happen. If you use lye and you use a liquid and unsaturated fat, then you get a liquid soap, all right? So over here, I want to show you a cool model. Now you've been playing with bubbles as a model of membranes, but I want to show you something else. So I made up my bubble juice just like you made up yours at home, and I used some straws to make a square framework. Now let's see if I can get this here. All right, let me lift that up. Okay, and then I took a little piece of just a little chunk of fishing line, and I made a little circle. I actually glued it together with a little bit of, come on, there we go. And I'm gonna float that right here like that, okay? So what I wanna model in this is I wanna model that this fishing line is kind of like a protein in the surface of the membrane. And look, it's basically free floating, and it makes a hole. It makes a channel. You might think of it as the nuclear membrane too, that has these holes in it. You learned about that, look. That's Micah's cat toy there. All right, that it can actually go through, and so here we've kept the membrane intact, and yet it can still have a movable hole, like a protein that acts as a gateway for things to get in and out of the membrane. Oh, come on, you guys, that is totally cool, don't you think? All right, membranes, soaps, kitchen biology. Bye.